Hello everyone, welcome back to your own chemistry channel and you're watching DMG chemistry classes. And in this video, I'm going to answer a very important and interesting question. Is delta G negative for forward as well as backward reaction in a reversible reaction? क्या किसी भी रिवर्सिबल रिएक्शन में फॉरवर्ड और बैकवर्ड दोनों रिएक्शंस के लिए डेल्टा जी नेगेटिव होता है? Because we have studied that in a reversible reaction both forward as well as backward reaction takes place, and we also know that delta G is negative for a spontaneous reaction, and we have also studied that if the delta G is positive for the forward reaction then it will be negative for the backward reaction. Okay, so if delta G is positive for the forward reaction then it will be negative for the backward reaction. This means that the forward reaction will be non-spontaneous and the backward reaction will be spontaneous. But in a reversible reaction both reaction occurs. Does it mean that delta G is negative for the forward as well as backward reaction? So I will answer this question during this video. So keep watching this video till very end and don't forget to like and share my videos and subscribe my channel. Okay. So friends, before answering this question, I would like to share some important points about the chemical equilibrium. So the chemical equilibrium can be attained from either side. It can be attained from the reactant sides as well as the product side. Chemical equilibrium को हम लोग किसी भी डायरेक्शन से अटेन कर सकते हैं. इसको हम रिएक्टेंट की तरफ से भी अटेन कर सकते हैं और प्रोडक्ट की तरफ से भी अटेन कर सकते हैं. Let us explain it with the help of a general reaction. That is, A is changing into B and this is a reversible reaction. So let us try to attain the equilibrium from the reactant side. So I will take A inside a closed container. Okay, then A will start converting into B. Okay, and after some time the B, as the concentration of the B will increase, the B will react to give back the reactant, that is A. Okay, so the backward reaction will also commence. Okay, and soon the rate of the forward reaction will become equal to the rate of the backward reaction and we will have equilibrium. So in this way we have attained the chemical equilibrium from the reactant side. Likewise, we can also attain equilibrium from the product side. So here I will take the product, that is B, inside a closed container, and then B will convert into A. Then as I explained, A will start converting into B and soon the rate of forward reaction and backward reaction will become equal and we will have equilibrium in the chemical reaction. Okay, so in this way the chemical equilibrium can be attained from either side. It can be attained from the product side as well as the reactant side. Further, a very important point is that the equilibrium reactions never go to completion. जो इक्विलिब्रियम रिएक्शंस होते हैं ना, वो कभी भी कंप्लीट नहीं होते हैं. मतलब जो रिएक्टेंट्स हैं वो कभी भी कंप्लीटली प्रोडक्ट में कन्वर्ट नहीं होते हैं. बीच में इक्विलिब्रियम आ जाता है. वी हैव इक्विलिब्रियम इन बिटवीन. ओके, सो दिस इज ऑल्सो अ वेरी इंपॉर्टेंट पॉइंट विच विल बी हेल्पफुल ड्यूरिंग द डिस्कशन. सो कीप वॉचिंग दिस वीडियो टू द वेरी एंड. Okay, so I am coming back to the question, that is delta G negative for the forward as well as backward reaction in a reversible reaction? And I will explain this question with the help of this chemical reaction which is written over here. So in this reaction 1 mole of N2O4, that is dinitrogen tetroxide or nitrogen tetroxide, is converting into 2 moles of nitrogen dioxide, that is NO2, and the delta G naught, that is the standard state free energy change for this reaction, is equal to plus 5.40 kilojoules. Okay, so as we can see that the standard state free energy change for this reaction is positive. Okay, and we have studied that if this free energy change is positive, then and this free energy change is for the forward reaction, that is for the conversion of your 1 mole of N2O4 into 2 moles of NO2. Okay, so as I said that we know that if the delta G naught is positive for a reaction, then it will be non-spontaneous. So from this value of your delta G naught, one might predict that the forward reaction, that is conversion of 1 mole of N2O4 into 2 moles of NO2, will be non-spontaneous under standard conditions. देखिए जो फॉरवर्ड रिएक्शन का डेल्टा जी नॉट है वो पॉजिटिव है, ठीक है, तो पॉजिटिव जो फॉरवर्ड रिएक्शन है वो नॉन स्पॉन्टेनियस होगा। इसका मतलब ये हुआ कि जो 1 मोल N2O4 का है वो डिसोशिएट नहीं होगा 2 मोल्स ऑफ NO2 में अंडर स्टैंडर्ड कंडीशंस। ओके, बट द बैकवर्ड रिएक्शन विल बी spontaneous. As I said that if the delta G is positive for the backward reaction, it will be is positive for the forward reaction, then it will be negative for the backward reaction. Okay, it means that the backward reaction will be spontaneous. Okay, so 2 moles of NO2 will be converted into 1 mole of N2O4. But both the predictions are wrong. Okay, दोनों ही जो predictions हैं वो गलत हैं, क्योंकि in this reversible reaction both forward and backward reaction takes place and both are spontaneous and the delta G will be negative for both of the reactions. Okay, so I will explain this question with the help of this free energy diagram. But before coming on to this diagram, I want to tell you that this delta G naught, which is positive plus 5.40, is for the complete conversion of 1 mole of N2O4 into 2 NO2. देखिए ये जो डेल्टा G naught है ना, ये तब है जब हमारा जो 1 मोल है N2O4 का वो completely कन्वर्ट होता है 2 मोल्स ऑफ NO2 में। लेकिन मैंने आपको एक्सप्लेन किया अभी कि जो इक्विलिब्रियम रिएक्शंस हैं दे नेवर गो टू कंप्लीशन, वो कंप्लीट होते ही नहीं हैं, बीच में क्या आता है, इक्विलिब्रियम आ जाता है। ओके, सो नाउ आई विल एक्सप्लेन द आंसर ऑफ दिस क्वेश्चन विद द हेल्प ऑफ दिस फ्री एनर्जी डायग्राम। सो अलोंग एक्स एक्सिस आई हैव द फ्रैक्शन ऑफ N2O4 डिसोशिएटेड। ओके, एक्स एक्सिस में हमारे पास क्या है कि कितना फ्रैक्शन N2O4 का डिसोशिएट हुआ है। ओके, अगर हम इक्विलिब्रियम को अटेन करने की कोशिश करते हैं रिएक्टेंट साइड से, ओके, देन द N2O4 विल स्टार्ट डिसोशिएटिंग। सो एट दिस पॉइंट 0.1 फ्रैक्शन ऑफ N2O4 विल बी डिसोशिएटेड। 0.1 फ्रैक्शन का मतलब ये हुआ दैट द 10% ऑफ N2O4 विल बी डिसोशिएटेड इनटू NO2, and here this means that 0.2 fraction of your N2O4 has been dissociated into NO2. 0.2 fraction means 20% of N2O4 has been dissociated into NO2. Okay, so in this way along the x-axis we have fraction of N2O4 dissociated, and along y-axis we have free energy change or the standard state free energy change. And this point A gives us the free energy of your 1 mole of N2O4 or the standard state free energy of 1 mole of N2O4, and this point B gives us the standard state free energy of 2 moles of NO2, and this is the free energy change, that is difference between the free energy of your 2 moles of NO2 and 1 mole of N2O4, and it is equal to plus 5.40, and as I said it is for the forward reaction and it is for the complete conversion of 1 mole of N2O4 into 2 moles of NO2. Understanding? And now this coming back to this curve, okay, so this curve will tell us about the free energy of the reaction mixture. Okay, as the reaction will proceed, then we will have the mixture of your N2O4 and NO2 in the reaction. So let us explain it. Now I am trying to attain the chemical equilibrium from the reactant side. Okay, so in this container I have taken your 1 mole of N2O4 gaseous. ठीक है, इस कंटेनर में मैंने 1 मोल ले लिया N2O4 का, and this container is under standard conditions, that is 298.15 degree Kelvin temperature and 1 atmospheric pressure. Okay, so as I explained that when the reaction starts, then the N2O4 will start converting into NO2. तो फिर आपका जो N2O4 है वो NO2 में कन्वर्ट होना शुरू हो जाएगा, and we will have both N2O4 as well as NO2 in the reaction mixture. तो दोनों होंगे फिर. तो with the help of this curve we can predict the free energy of the reaction mixture. Okay, suppose here I have your 0.5 fraction. Okay, this means that at this point 5% of N2O4 will be dissociated into NO2. इस पॉइंट के ऊपर आपका 5% जो N2O4 है वो डिसोशिएट होगा किसमें, NO2 में. तो रिएक्शन मिक्सचर में दोनों हुए, फिर NO2 भी हुआ N2O4 भी हुआ, तो उसकी फ्री एनर्जी हम इस कर्व से निकाल लेंगे, लाइक दिस एंड दिस. So this will be the free energy of the reaction mixture at this point. And here we have fraction is 0.1. This means that at this point 10% of the N2O4 will be dissociated into NO2. Okay, and we can have the free energy of the reaction mixture like this, and this will be the value of the free energy of the reaction mixture after 0.1 fraction of your N2O4 has been dissociated. Okay, so this curve will tell us the free energy of the reaction mixture. Okay, so now let us explain it further. So as the reaction progresses, N2O4 is converted into NO2, and here we have a minima in this curve. इस कर्व में यहाँ जो पॉइंट E है, we have minima at this point E, and this point E is the equilibrium point. ठीक है, and this equilibrium point comes when the 16.6% of your N2O4, 16.6% of your N2O4 is dissociated into NO2. और इस पॉइंट के ऊपर जो है इक्विलिब्रियम आ जाता है, और इस पॉइंट के ऊपर 16.6% N2O4 डिसोशिएट होता है NO2 में. ओके, देन व्हाट विल बी द परसेंटेज ऑफ NO2 हेयर. तो NO2 की जो परसेंटेज होगी इट विल बी इक्वल टू द परसेंटेज ऑफ N2O4 डिसोशिएटेड, क्योंकि NO2 उतना ही बनेगा जितना N2O4 डिसोशिएट होगा. तो इसका मतलब ये हुआ कि at point E, which is our equilibrium point, the percentage of your, we will have your 16.6% NO2 and 83.4% N2O4, क्योंकि उतना ही NO2 बनेगा जितना आपका N2O4 डिसोशिएट होगा. और कितना डिसोशिएट हुआ इस पॉइंट पे, 16.6% हुआ है. सो दिस इज आवर इक्विलिब्रियम पॉइंट. ओके, एट दिस पॉइंट रेट ऑफ फॉरवर्ड रिएक्शन बिकम्स इक्वल टू बैकवर्ड रिएक्शन. नाउ वी विल डिस्कस द स्पॉन्टेनिटी ऑफ दिस रिएक्शन फ्रॉम दिस पॉइंट टू दिस पॉइंट. ओके, अब हम लोग इस रिएक्शन की स्पॉन्टेनिटी देखेंगे रिएक्टेंट से लेकर कहाँ तक, इक्विलिब्रियम मिक्सचर तक. तो यू आर क्लियरली सीइंग हेयर दैट द फ्री एनर्जी ऑफ द इक्विलिब्रियम मिक्सचर इज लेस देन द फ्री एनर्जी ऑफ द रिएक्टेंट्स, दैट इज 1 मोल ऑफ N2O4. क्योंकि यहाँ पे दोनों होंगे, जो पॉइंट E है यहाँ पे दोनों हैं, आपका N2O4 भी है और दोनों अब इक्विलिब्रियम में है, आपका NO2 भी है, एंड बोथ आर इन इक्विलिब्रियम. तो जो इक्विलिब्रियम मिक्सचर है वो हमारा एक तरह से प्रोडक्ट हुआ, ठीक है, और A क्या है, हमारा रिएक्टेंट है जो 1 मोल ऑफ N2O4 है. तो इस पॉइंट पे आप बिल्कुल साफ देख रहे हैं कि जो फ्री एनर्जी है इक्विलिब्रियम मिक्सचर की वो कम है और जो रिएक्टेंट की जो फ्री एनर्जी है वो ज़्यादा है। तो इक्विलिब्रियम मिक्सचर हमारा प्रोडक्ट हुआ। दिस मीन्स दैट द डेल्टा जी नॉट ऑफ दिस रिएक्शन विल बी इक्वल टू द फ्री एनर्जी ऑफ इक्विलिब्रियम मिक्सचर। ओके, क्योंकि ये एक तरह से प्रोडक्ट बिहेव करेगा हमारा ये फ्री एनर्जी ऑफ इक्विलिब्रियम मिक्सचर माइनस फ्री एनर्जी ऑफ योर रिएक्टेंट एंड दिस विल बी नेगेटिव। और ये नेगेटिव होगा, क्यों होगा? क्योंकि ये फ्री एनर्जी कम है और ये फ्री एनर्जी ज़्यादा है। ठीक है, एंड द फ्री एनर्जी चेंज इज and the free energy change of this reaction is minus 0.84 minus 0.84. Okay, and we can also explain it by giving some imaginary values here at point E. So let the free energy at point A is your 2.0 kilojoules and at point E we have free energy equal to 1.14. Okay, then the delta G naught, that is the difference in the free energy of equilibrium mixture and the reactant, it will be equal to 1.14 minus 2 and it will be equal to minus 0.86 kilojoules. Okay, but these two values are imaginary. I have supposed these values to make you people understand what this free energy change is real. This is actual. Okay, so you are clearly watching here that the delta G is negative from this point to this point, that is from the reactant to the equilibrium point. So this reaction is spontaneous from the reactant side up to the equilibrium point because delta G is negative. Now let us try to attain the equilibrium from the product side. So what I will do here, I will take 2 moles of your NO2 in a closed container, and in the beginning we will have 100% NO2 in this reaction, and soon the reaction will commence and the NO2 will start converting into N2O4. So at the point B we will have 100% NO2. Okay, then as the reaction progresses the NO2 will start converting into N2O4. So at this point, okay, at this point 0.1 fraction of NO2 will be converted into N2O4. तो यहाँ पे 0.1 फ्रैक्शन जो NO2 का है वो कन्वर्ट हो जाएगा किसमें? 0.1 फ्रैक्शन मीन्स 10%. तो 10% NO2 जो है वो कन्वर्ट हो जाएगा N2O4 में, और at this point 0.2 fraction will be converted into N2O4 and at this point 0.3 fraction, that is 30% of your NO2 will be converted into N2O4. Now I am talking about the backward reaction and we are attaining the chemical equilibrium from the product side. And we can have the free energy of the reaction mixture with the help of this free energy curve. So okay, when this when 30% of your NO2 has been converted into N2O4, then this will be the free energy of the reaction mixture. Okay, so now the reaction will continue in the backward direction. NO2 will start converting into N2O4 and soon we will reach here again, that is we will reach at point E, which is the equilibrium point. And here, as I explained, that 83.4% NO2 would have been converted into N2O4. इस पॉइंट E के ऊपर 83.4% जो NO2 है ना वो कन्वर्ट हो चुका होगा किसमें? N2O4 में. ठीक है, तो फिर से जैसे मैंने पहले एक्सप्लेन किया कि इस पॉइंट के ऊपर N2O4 की जो परसेंटेज ऑफ योर N2O4 होगी वो कितनी होगी? वो 83.7 6% होगा और जो NO2 होगा वो कितना बचेगा, ये आपके पास 16.4% होगा, या सॉरी इट वाज 83.4 एंड इट वाज 16.6%। तो इक्विलिब्रियम तो वहीं आएगा जहां आएगा, और इस पॉइंट पे फिर से वही कॉन्सेंट्रेशंस होगी जो इस साइड से थी, कितनी 83.4% N2O4 और 16.6% NO2। ठीक है, नाउ वी विल डिस्कस द स्पॉन्टेनिटी ऑफ द रिएक्शन फ्रॉम दिस पॉइंट B, ओके, to up to the equilibrium mixture or the equilibrium point. Okay, so that is you are clearly seeing here that here also the free energy, okay, the free energy of the equilibrium mixture or the equilibrium point is less than the free energy of the products. Okay, so here the free energy of the equilibrium mixture minus the free energy of your products will be negative. So this reaction is again spontaneous in the backward reaction up to the equilibrium point. और चलिए इसको कुछ वैल्यू के साथ एक्सप्लेन करते हैं। तो जैसे इसको मैंने एक वैल्यू असाइन कर दी थी 1.14, इसको 2.0, तो इस वैल्यू को भी वैल्यू दे देते हैं और ये वैल्यू आपका हो जाएगा 7.40। ठीक है, तो इक्विलिब्रियम मिक्सचर हमारा प्रोडक्ट हुआ, तो इसकी जो फ्री एनर्जी है वो कितनी हो गई 1.14 है। ठीक है, और जो हमारा पॉइंट बी है, इसकी जो हमारे प्रोडक्ट्स हैं उनकी जो फ्री एनर्जी है वो कितनी हुई 7.40 हो गया। तो जो डेल्टा जी आएगा वो कितना आएगा, दैट विल बी -6.24 किलो जूल्स। तो आप देख रहे होंगे कि जब हमने प्रोडक्ट साइड से इक्विलिब्रियम को अटेन करने की कोशिश की तब भी इक्विलिब्रियम जहां आना था वहीं आया, और जो डेल्टा जी है वो नेगेटिव है। ओके, फॉर द बैकवर्ड रिएक्शन ऑल्सो अप टू द इक्विलिब्रियम पॉइंट, सो द बैकवर्ड रिएक्शन इज ऑल्सो spontaneous. And we can also calculate this free energy change in 2 steps, that is from this point to this point and from this point to this point. Okay, so from E to A the free energy change is your from E to A the free energy change is your 1.14 minus 2, and it was equal to minus 1.16 minus 2, so it was equal to minus 0.84 kilojoules. And from A to this point, let this point is your D, so then from your A to D the free energy change is, that is 2.0 minus this 7.0. okay, then it will be equal to minus 5.40 kilojoule. So the total free energy change delta G naught is equal to minus 0.84 minus 5.50, and it will be equal to minus 6.24 kilojoules. Okay, so in this way we can also calculate this free energy change in 2 steps, that is from this point to this point and this point to this point, and the value will be same, that is minus 6.24 kilojoules. Okay, so in this way I have explained that both forward and backward reactions are spontaneous up to the equilibrium point because their delta G is negative. Now let us elaborate it somewhat further. So let us try to attain the chemical equilibrium from the reactant side also. Again, so here in this container I am taking your 1 mole of N2O4. So the 1 mole of N2O4 initially, and then reaction will start and it will start converting into NO2. तो ये NO2 में convert होना शुरू हो जाएगा। क्यों? Because the forward reaction is spontaneous up to the equilibrium point, and soon the concentration of NO2 will increase and we will have backward reaction also. जब NO2 की concentration बढ़ेगा तो NO2 जो है वो भी convert होना शुरू हो जाएगा N2O4 में, because the backward reaction is also spontaneous. okay, because the delta G is also negative up to the equilibrium point. तो फिर बैकवर्ड रिएक्शन भी शुरू होगा, दोनों ही स्पॉन्टेनियस हैं इक्विलिब्रियम पॉइंट तक, तो बैकवर्ड रिएक्शन भी शुरू हो जाएगा. And soon this stage will be reached where the rate of forward reaction and rate of backward reaction will become equal, okay, and we will have equilibrium. Okay, so in this way I have answered this question that delta G is negative for the forward as well as backward reaction in a reversible reaction, and both are spontaneous. But if we talk about this point E, अगर हम इस पॉइंट E की ही बात करें तो एट पॉइंट E वी आर हैविंग बोथ, हमारे पास रिएक्टेंट भी होते हैं, इक्विलिब्रियम मिक्सचर होता है ना ये, तो हमारे पास रिएक्टेंट भी होते हैं और हमारे पास प्रोडक्ट भी होते हैं, दोनों होते हैं, ठीक है, और वी हैव इक्विलिब्रियम मिक्सचर. देन एट दिस पॉइंट, नाउ आई एम टॉकिंग अबाउट दिस पॉइंट ओनली, एट दिस पॉइंट द free energy of your reactants will be equal to the free energy of the product, and Gp will be equal to Gr. रिएक्टेंट और प्रोडक्ट की फ्री एनर्जी क्या होगी इस पॉइंट पे, बराबर होगी, एंड Gp माइनस Gr will be equal to 0 और Gp नॉट, because reaction is occurring under standard conditions. Then Gp minus Gr will be equal to 0. This means that delta G naught will be 0 at this point E. Understanding? So because as I have explained that delta G is equal to 0 at the equilibrium point. So this is all about this question, that how the delta G is negative for forward as well as backward reaction. And in my next video I will discuss the thermodynamic derivation of your law of chemical equilibrium. So keep watching my videos, like and share my videos, and don't forget to subscribe my channel. Thank you very much.